warm greetings to one and all. It's my privilege to welcome all of you to this webinar session on behalf of ECE Department of Francis Xavier Engineering College. Seeking the blessings of Lord Almighty, I invite Mr. Premanand, Assistant Professor of ECE Department, to start the session with prayer.
Prayer. Father, we thank you and praise you, God, for all the blessings, for all the goodness, for all the happiness you have showered upon us. Father, we pray for our college, our chairman, all the teaching and non-teaching fraternity, God. Bless them and be with them and give them good health, God. Father, we pray for this webinar, Engineering Culture and Technological Evolution. Father, bless our resource person, Mr. Abdul Riyaz, Engineering Manager, Optum, United Health Groups, Hyderabad. Bless our webinar coordinator, Dr. Lakshmi Narayanan sir, Jayaraman sir, and Kannan sir. And bless all the participants, God. Let this seminar be a fruitful one for all the participants, God. As your word says, I will bring health and healing. I will heal my people and will let them enjoy abundance, peace, and security. Jeremiah 33:6. God bless us with good health, peace, and security. We ask and pray in the name of our Lord and Savior Jesus Christ. Amen.
Now I invite Mrs. J. Friska Ma'am, Head of Department, Electronics and Communication Engineering, to deliver the welcome address.
Great things happen when there is a gathering of great minds. It gives me immense pleasure to deliver the welcome address in this greatest gathering. On behalf of Francis Xavier Engineering College and the entire teaching fraternity of Department of ECE, I would like to extend a very warm welcome to all the delegates who have joined with us today. First of all, I would like to record my heartfelt gratitude to Lord Almighty for His manifold blessings on each one of us. I would like to place my sincere thanks to the management of Francis Xavier Engineering College for motivating us and behind us in all our journey towards excellence. I feel extremely delighted in welcoming speaker of today's session, Mr. Abdul Riyaz, Engineering Manager, Optum United Health Group, Hyderabad, who has accepted our invitation and joined with us to share his experience and expertise with us. We welcome you, sir. I would like to extend a cordial welcome to Dr. V. Velmurugan, sir, Principal, Francis Xavier Engineering College, to this August gathering. We welcome you, sir. I would like to welcome the coordinators of today's event, Dr. K. Lakshmi Narayanan, sir, Mr. Jayaraman, sir, and Mr. Kannan, sir, for their strenuous effort in connecting an eminent resource person with us. I would also like to welcome the participants from academic institutions, industries, students who have joined with us across the states and across the globe to get practical insights. The ECE Department of Francis Xavier Engineering College prepares students to face the challenges of tomorrow. The department has been NBA accredited and has received a grant from Department of Science and Technology, Government of India, and it has received permanent affiliation from Anna University. Our department is Anna University Recognized Research Center. The department offers academic programs at the undergraduate and postgraduate level. To enhance the employment and entrepreneurial potential of the students, the department has successfully established a rapport with MNCs, corporate industries, higher learning and research institutes in India and abroad. With a strength of dedicated and dynamic faculties, ever supportive management, and well-motivated students, the department is fully geared up in its pursuit of attaining excellence in engineering education with ethics. May I take this opportunity to convey my very best wishes for an effective, successful, and productive session ahead. Thank you for the opportunity given. Thank you.
Now I request Dr. K. Lakshmi Narayan sir, Assistant Professor, ECE Department, to introduce our resource person, Mr. Abdul Riyaz.
Good morning to everyone. This is Dr. Lakshmi Narayanan from Francis Xavier Engineering College. It gives me immense pleasure in welcoming today's guest, Mr. Abdul Riyaz, Engineering Manager, Optum, United Health Group. Mr. Abdul Riyaz completed his engineering in Government College of Engineering, Tirunelveli, our hometown. He started his career as a program analyst in Cognizant Technology Solutions through campus recruitment. Post 2 years of experience in Cognizant Technology Solutions, he have been recruited by United Health Group, and presently he's having 13 plus years of experience in IT, software development, and in US healthcare. United Health Group is a leader in US healthcare, and it stands first in the most admired companies in the field of healthcare, and it stands sixth in the Fortune 500 companies. Currently, Mr. Abdul Riyaz is engineering and managing one of the key business unit of United Health Group in production service. His area of interest includes cloud, machine learning, NoSQL, database, programming, and engineering. So without any further delay, I hand over the session to Mr. Abdul Riyaz. Thank you very much.
Hey, hello all. Good morning. I am Abdul Riyaz, and I work as engineering manager. I work for Optum, United Health Group. First of all, to start with, I would like to say thanks to Lakshmi Narayanan for, AP ECE department for inviting me. And thanks to the management for approving this, and thanks to all faculty members, and thanks for everyone who are joining in, and thanks to the engineers who are taking time to join this presentation. I hope you might have seen the poster. The topic is engineering culture, actually. So I would say, like, it's loosely, in generic to all engineering streams, but strongly, I would say, related to the computer science or the software or the information technology, IT streams, actually. So you might wonder, like, what is this? If you have heard of this topic before, well and good. So it would be a reminder call for you. If you have not heard of this engineering culture, so you might think like, what is this actually, or why this topic? So, for example, even I also ask myself when I have been invited, like, what kind of session I can spend in this, couple of minutes actually. So I was thinking of the areas which I work, like cloud, or the other buzzwords like NoSQL DB, um, the normal data to big data, or the any programming languages that's going to help us in the next upcoming year, something like that. I also thought about all those topics, but I felt like definitely one or the other way, definitely you will get you will get to know about those topics, either through your institution or through from other speakers. I felt like you will definitely get to know about those topics actually. So I was thinking, like, what else I can share in this time. So I felt like what is very important now, and again, I'm sorry to say, what is missing in engineers, okay, the surrounding us actually. So that's what I felt. This is very important. Engineering culture is very important, and it is already started taking a pace now. And I would like to remind again, like, it is very, very important, and we see it's missing in the with the engineers actually. That's what I thought. Like, okay, let's touch this point because this is very critical now, and I thought we should touch this one to give a reminder to those who are already aware. Those who are not aware of this, they should be aware of this by now for sure actually. Okay, a lot of stuff actually. So moving on, the topic engineering culture. So it's a very brief definition, I would say. So engineering culture is nothing but set of values, that drives what we do as engineers. So what you are seeing in my slide actually talks about that actually. So engineering culture is a set of values that's going to drive us. So drive who means the engineers. So engineers, 4 years of engineering education. So there were a lot of, I want to touch upon education, like there were a lot of definitions or brief statements about education, but what I like more is education is train your mind to think. So education is train your mind to think. Actually, that's the say I really like a lot. So 4 years of engineering education, which means 4 years you're gonna train your mind to think, and through those thoughts, you're gonna help the world. You might be healing the world through your ideas and thoughts actually. So, but I would like to ask you all who are listening to this. So, how many of you are really thinking that you are spending your time to think? I mean, the 4 years. So, as I say, like education is trying to mind your think, right? So, how many of you are really spending your time to think? So that I want to remind that statement. So engineers 4 years, so that education actually. So again, engineering culture industry already started. It's been years actually. They started a lot about engineering culture. So this been a question for during your interview also. If you might be facing this if you have not, and so this is going to be very critical actually. So as an engineer, what are you going to do? And like I would say, like engineering culture will drive you, as the definition says. So you should not just be in order taking mode, like someone will say something to you and you will just work on it. That's not going to work for sure, friends. Please make a note of this order taking mode. Someone tells some requirement and they will tell how to do, and you will apply and you will work and you will know. So they are now trying to get the engineering out of you kind of engineers actually. So that's the reason. A lot of stuff before we start. So as I mentioned, I want to underscore like set of values. So let's see, like I said, very critical. The industry already started expecting this. It's not late, but already started. So you also should know about this. So let's talk about quickly about a couple of set of values. I would say it's not limited to whatever I'm going to show. You can improvise. In future, someone might definitely add. So before we see the set of values, I want to talk about this one line, like organizations are changing the way how we build or how we develop or how a software is being built. Okay, right. So as I already told, this topic is for all the engineering streams, in general to all engineering streams, but strongly related to software or IT. So that's what I mentioned, software being built. So organizations, this is just one line, organizations are changing the way how we build. But friends, a lot of things going on. Change, it's keep on changing actually. So what do you assume today? Like something would be like this. It is getting changed in a week or in a month. It's completely changed over a period of months actually. So you all should remember this. Things are keep on changing actually. So for example, I would say, if you see my designation, it's engineering manager. So a couple of years back, then all like project manager, something like that. So it all changing actually. Just an example I'm quoting. So now the organization are changing, and how they are changing means they are using the set of values which I'm going to show you. So engineering culture set of values I'm going to show actually. So what you see is like it's automation, test automation. So keep it like it's one value. Data, then decision, measure everything, anything, and deploy early and optimize too often. Then continuous learning, reviews. The next value, blameless postmortems. For the next value, autonomous teams. I would say an environment. Okay, so these are all the values I'm going to talk in next couple of minutes. But I would like to remind friends, like, the values are not just limited to this, but these are all very important values, and values of engineering culture, I would say. So moving on, let's talk in brief about these values. And yes, I'm just moving on. Automation and test automation. So, yep. So something, a chopper is coming up. Okay, I will explain. And then there comes a drone. I'm sure, like, we are living in a world of information. I'm sure, like, many of you would have seen this comparison. A chopper. So someone is holding a camera. They are taking a video of whatever be it. But now, what we need instead of that, right? Fans to carry the camera, and needs to just an automation, some remote to make that fly. And you might have seen a lot of videos on a news channel as well, that the police department, how they are using the drone to make sure people maintain a self distancing actually. So just see this automation. There was a chopper and a pilot and someone to carry the camera, and the camera is there. We have ignored everything now, and we have a drone. So automated and minimized actually. So this is, I would say, not a strong example, but just I want to start like this. Okay. So automation and test automation. Let's, for an example, why I'm going to talk more about this value. But before that, just think that you are creating a website. Okay, so you being a software, be creating a website, or someone creating some manufacturing something mechanically or something they are creating. So over the period of time, when it is going to grow, be it a website or whatever you are creating, be it is going to grow. Believe me, friends, the operational burden is going to increase like anything. So when you have a lot of engineers in your team, that time is going to spend more on operational burden actually. So the reason is, when something is growing, the operational burden also will grow. So what happens is, the engineers spend more time on operational burden, and they are not able to concentrate on the innovative stuff actually, or the real problems actually, or any enhancements. So we need to minimize this operational burden. This is a very important aspect, and that comes the automation. So the application growth increase operational burden, and so automation is the key to reduce the operational burden per engineer. I already told this, right? So for an example, see this: the repeated tasks should be automated through scripting or whatever way you find it possible. Let's say I already told you have a website, and that website has a lot of service, associated service. Let's say if it is failing, it should be automated through healing, self-healing, auto-heal. Okay, so let's say your website, it is designed for 100 users at a time, but all of a sudden you have added very important data, and users across India is accessing your website. So what happens? The traffic towards your website is going to increase like anything, and your system should automatically increase, for example, the infrastructure for that. Okay, it should scale up, right? So for you have designed for 100 users at a time. So when 1 lakh users are going to come, means what do you do? So when 1 lakh users gonna come, what do you do? So your system should be automatically scale up. So how you design for that? So that comes automation on, I would say, in various shape, like repeated tasks, scripting. I already told failing service. You are going to create self-healing concepts. The peak traffic, something I told that you're going to auto scale up. I mean, auto spin up or auto spin down. So how the technology evolved over the period of years. For example, a couple of years back, it's not a couple of years, some years back, a decade back, for example, let's take an example. So the repeated task, it will be repeatedly done manually, and they feel comfortable, they feel settled to do that. And I would say, like, they will be happy with everyday heroic fixes. You should mark this, everyday heroic fixes. So how to fix this permanently, that was not in that. So that was happening. So talk about this failing service, how it was happened. So we need to call someone, they will come up, and they're gonna what's that? Start the service, which is stopped, actually just failed. So the peak traffic condition, think about that. So we just say the website is not available. Yes, right. So I'm talking about some years back. So we just say the website is not available, but now it should. Now we are trying to automate everything. Resolving the issues also should be automated. And upcoming years, think about that actually. So when I say upcoming years, so how this should be? You need to create a machine learning and artificial intelligence coupled. That should make sure that, for example, take this failing service. That should make sure that, okay, it should automatically, it should judge, the intelligence should tell you like, okay, this might fail now, so heal it before it fails. So we're gonna like to a situation like it won't even think of failing actually, the service. So that's in future. So this is how the technology is evolving. So I talk about engineering culture, values, and I also talk about, the technology evolution actually. So you need to just make a relation between that. And then comes the automated test pass flow. The world is moving towards this. Please understand this. Like your testing should be completely automated end to end actually. So whatever be the test, regression, smoke, or whatever be the test, it should be automated end to end so that the deploy will be quick. So automation is it's very, very important value. So you being an engineer should come with that actually. So automation is very, very important actually. Strive for that actually. So that's what I would say in this actually. And this is all about automation. And moving on, the next value, data arrow decision. So you can take it like data driven decision. So decisions are not made through opinion or ego or intuition or authority, whatever be it. So let's say you are a team of engineers and you need to take a decision. It should not, be made through someone's opinion or an ego or someone like an authority or your intuition. It should not be made. You as an engineer should make sure this value, like decision should be made through data. This is another important value. So it's data that drives the decision. So data-driven organizations are 3 times more likely to. So this is a fact actually. So I just want to show you. Okay, so it has reported significant improvements, which has improved. I mean, improved means that is a data-driven organizations. And for example, I just showing like COVID-19 data. So we have a lot of data. So if at all a pandemic or epidemic going to occur in future, this data should help us in guiding and make sure the impact on economy, people should be reduced. You as an engineer to make use of this data. So I would say you can do some, I would say some work on this actually, you being an engineer. So when you have, when you want to decide something with the data, okay, with the data, not without it, with the data, you will be like more proactive, and there will be a lot of cost savings when you go with the data, and you will be more confident. Okay, so for example, in recent times, leaders used to say, follow your intuition, and in old books also, you could have heard like, follow your intuition. Yeah, fine, but not always. Data is going to help and give a confident decisions actually. So data is precious, and okay, why I'm saying we are in data age, I will just talk about that actually. And moving on, this is just an example I want to show, like take about the current ongoing COVID situation. So you all might have heard in news as well, like there is an expert committee formed, which is like senior experts might be there, and action committee, which comprises of the ground, the folks who are going to execute that on ground actually. Who is that actually. But see here, the data that lies on top, So you are engineers, you are going to manage this data. So you should be knowing that you should smartly utilize this data or give those data smartly to the expert committee so that things would be done effectively. So that's what I want to remind you. Engineers are very, very important in this cycle. So especially the data here. And so here I want to touch two things. Okay, so yeah. So for example, I will just talk about it later. But so now I'm just going to show you like what are all the ages we have crossed. For example, we were in Stone Age, and then comes up Bronze and Iron Age, Middle Age, the Renaissance, Industrial. Then comes the autumn stuff, right? Then we have shown a lot of interest on space age, and then come the information age or digital age, whatever you call it. And now we are in data age. Data is very, very important. So you engineers have the responsibility to receive the data, store the data in a smart way that helps us, that is going to help the world actually. So data-driven decision is another important value, and data is very, very important. So when I say automation in the last slide, and now data-driven decision, so I also tell you like, for example, please do some homework. Like, for example, I was talking about automation, right? The failing service. Just do a research about self-healing, or moving on, like I was talking about scale up, scale down. I mean the spinning up, spinning down. So please do a research on Kubernetes, Docker Swarm, or any orchestration stuff. Orchestration, okay. Do a research on that. Do a self-learn, I would say. And coming to data-driven decision, I would say like how the data are, presented. For example, here I would say, please do a self-learn on what's Tableau, how data are utilized in that, so something like that. So two values, we talked about two values. So one is automation, now we are into data-driven decision. So this is just a depiction. This picture is saying like, if you are having, two direction, one is like, we don't have anything. It's all about intuition, authority, all those things. But the other end, if you have data, we would strongly say, you be an engineer, we would recommend like, follow that. So data-driven decision makes more sense actually. Okay, so a lot of stuff about automation and data-driven decision. Two values, but I would like to, highlight, underscore something. Friends, so when we talk about automation and data-driven decision, so it's all about system, right? So we are talking about, let's say, for example, system, and data means you're going to store that in data centers, right? So here comes, I want to show some relation, like, for example, when you do any workout, right? When you work out, what happens? Your body produces heat, correct? The same way, when you run your system, a server or your laptop, it's going to produce again heat, right? So in the name of automations, in the name of data engineering, data centers, all those things, we should not create unnecessary systems. I'm telling about unnecessary, not about necessary, unnecessary systems, because that has an impact on our environment. You are not just an engineer, you should be a responsible global citizen as well. So if we talk about data automations, that should not create unnecessary systems actually. You should smartly create needed, necessary systems actually. So the focus on data storage and continuous automation should not create unnecessary system. That's what I'm saying actually. For example, why I'm saying this is, why I'm talking all about this is, see, like that's what I told. The human beings should not think like, okay, system is immortal, like that kind of stuff. You should not think like, so that to produce heat, that too has a life actually. So you should not keep on replicating the systems, because you need to just invest, right? Because creating, a human being takes time, but creating a system won't take time. So in that sense, you should not do that. So for example, I'm going to show an example. See this. I usually show this to many of the engineers, like see this one, like see we used to live in huts some years back, right? The same way we do have a low cost servers. It's not low cost actually. I could say low configured servers, less configured servers. So like this, hut we used to live. I mean, our forefathers and predecessors. Then we move to a concrete home. Actually, it has one foundation. A family lives in this a single concrete home. The same way, the evolution happened like this. Like we have a hardware, and there would be one operating system. OS stands for operating system, and it has one operating system. Like that, one home we have, and it has one foundation. One family lives there. The same way, one server as like foundation, we have one hardware, and then we have one operating system as like a family. Then what happened? The apartment culture started because of cost. What we thought, let's go and stay in apartment. So here we have only one foundation, but lot of units, lot of families used to live in individual flats. So this is for cost wise, and also uh, space is also reduced, right? Lot of savings here. The same way, if you see here, it's one foundation, as I already told. There were a lot of OS using the hypervisor. Do a homework like what is hypervisor, how it is used, that one. So lot of, I told lot of flats. You just imagine like each flat, each OS is each flat, something like that. Then what happened? Group of blocks, apartment blocks that forms a community. Okay, so lot of blocks actually. The same way, lot of stuff. So why I'm showing this comparison means the thought process is same. If you see here, it's one foundation, just one foundation. Again, one foundation, many flats, one foundation, many OS. Now a lot of stuff. So now we are also building a lot of stuff on top of things, right? So the thought process is same, and so as an engineer, we should not think like this computers, servers, or something else. No, that's also a child of our thoughts only, our thought process only. So we should utilize it, I would say efficiently, okay, meticulously. So see this one, coming to the data strength. So many years back, right, we were like 50 kbps speed was considered great. Then we upgraded to 145 kbps. Then comes the 10 mbps speed, and then comes the 1 GB per second that speed actually. So this is how the data, the network that has evolved actually. So again, the thought process is same. So everything should be used meticulously, otherwise it's going to impact the environment. So that's what I want to show this relation actually. Okay. So just some 4 points quickly. I will move on. Like 3% of global electricity supply is being used for data centers. Data centers actually, right? So 1/5 of global electricity will be used by the data centers by 2025. 1/5 is estimated. And data centers, it was like 500K we had in 2012, but now it spiked like 8 million data centers. So these data centers, right? These data centers, it's going to produce a lot of heat. It's going to increase the temperature. So that's what one adverse impact of data centers. That's what some leading organizations, what they thought. Okay, let's have our data centers in cooler parts of the world, like the Siberia or the cooler parts, like that they were thinking. And the only issue is like when you carry data from your country to a cooler parts of the world, okay, which means ideally you are carrying your data from one country to other country, that the local laws prevent that. So this is again an issue. So you being an engineer, we need to come up with some solution for this. Um, you are an engineer, the same time you should be a global citizen. Okay, that's what I want to mean. All this is very, very important. Okay, moving on, the third value, measure everything, anything. This is very, very important value, friends. Believe me or not, this is very, very important actually. So you need to measure everything. You being an engineer, you should measure everything actually. So how you would measure means, so how you're going to measure is like through monitoring actually, right? So if you want to measure something, if you want to measure how fast the cloud is moving, you need to monitor that, right? That's what you do, right? So monitoring would be done real time, right? You can just see the cloud, okay, how fast it is moving. For an example, I'm saying, or you can also do a recording, and later you will go and see, after some point of time. So that is like you can do either in real time, or you can collect store and later you will be monitoring. And I don't touch this point. I will tell you later. So measurements through monitoring, right? So you need to measure everything and anything. That's the important value of engineering culture. So how you gonna monitor this means that is going to help you improving the stability. Okay. Again, talk about the website I told. Let's say a website of Francis Xavier, for an example. Let's take that. So you need to keep on monitoring who is accessing this, how many users are accessing. Okay, Sunday at this particular point of time, a lot of users are accessing. Okay, then I need to spin up. Okay, or you need to increase something like that. That kind of scalability performance will be improved through continuous monitoring actually. So, and one more thing is we talked about automation. Monitoring, measuring will give inputs to effective automation, right? So here, how years back, how we were monitoring means, for example, I will tell our case, like the logs will be stored in, let's say, a text file. We open the text file, that would be a, let's say, a 10 MB log or 20 MB log. I'm talking about that time. Now it's created GB, right? So at 10 MB or 20 MB logs, we used to go through line by line, search particular word. Okay, what is the issue? This, that, and what is the statistics which we used to collect from that log. That's what we were doing a decade back or more than that, I would say. But now I would request you to check about these buzzwords. What is this? Grafana, Kibana, Graphite, Prometheus, Splunk. So now, for example, if I have a text file full of data, for an example, I'm saying, I will just give as an input to one of these tools that is going to give you a beautiful visual dashboards, visualizations, statistics. So you no need to do a lot of manual work. So now we have the technology evolved and you can easily measure. We can also do continuous monitoring using these tools. So I would say, please do a little self-learn about these tools. That will really help you. Okay, how the technology evolved. You as an engineer should remember this value, which is measure everything and anything, and at the same time learn this, know about this technology as well. Okay, so we are done with 3 values. Moving on, the next value is optimize to deploy early and often. Okay, in the very beginning of the slide, right, we have seen like we have seen like organizations are changing the way how they build, develop like this. That was a definition, right? Sorry, a statement. So how they build, how they deploy. Okay, so when you build something, when you develop something, you need to deploy it. So the next value is whenever you deploy, make sure that you deploy early and often actually. This is very, very important. So for example, if you are, let's say you are developing a website, again, let's say for Francis, your FX website. So for example, when you keep on developing for 6 months and after 6 months you deploy, means the engineers who are working, right, they actually lose interest. The work motivation won't be there. So that's the reason we say optimize to deploy early and often, which means you need to break down the requirements or features into multiple small changes and make sure that you deploy it early and often. So gradual rollouts should be there. It should not be a big bang release. That's what I told. You will, hundreds of requirements will be there and you will keep on completing all the hundreds of requirements. And then you deploy once in a blue moon, like in 1 year, which means your engineers will lose the interest. Their work motivation will be gone and won't be no excitement actually. So if you deploy early and often, multiple small changes instead of 100 changes at one time to deploy 10, 10, 10. So that is going to increase the interest actually. So at the same time, you need to make sure that your application is also available when you deploy. So for example, think about Google or Facebook, WhatsApp, whatever you use. So how many days or time you remember that they said not available? So ever thought about that? Like how come they keep on improvising their applications, but have you ever thought like you might have not seen like something like not available or freezing? Nothing. That's freezing screens of their applications. No, right? So deploying early and often at the same time, you need to make sure the application is still running or the unavailable or the application availability, it should be impacted very minimal actually. So for example, now the human mindset is like we are all moving to one mindset, like even though we don't want to see something 24/7, but still we don't want to see not available. For example, if I don't see Facebook 24/7, right? I don't see more than 1 hour or so, but I really don't want Facebook saying me I won't be available for this time. Okay, that kind of mindset, we can't help that. The human mindset is moving towards that. So you being an engineer, to develop something, build something, deploy early and often, break the futures, okay, break down that, and make sure that the application is still working. Whatever you have created is still working when you deploy something. So that's what we are all, when I say like we are all deploy early and often, we are moving towards agile from waterfall. So if someone who have never heard of this, please try to learn about this agile waterfall. What is that? And I would say like a couple of years back, I mean, we were like deploying once in 6 months, then once in quarter, then it comes to once in a month, then bi-weekly, which is like twice in a month, then it becomes weekly deployment. So this is how it was evolving actually. So this is another important value you as an engineer should know about this actually. So when you come out of your engineering stream and go for an industry, you should know this. You should not create something for years and deploy. No, that's not going to help actually. Okay, moving on. It is very, very important. Continuous learning is another very important value. Remember the chopper and drone case, which I have shown in the initial slide. So things which was used, which was very popular years back, won't be popular, right? So the chopper case, right now it is drones are being used. So you need to keep on upgrading yourself. That's the ultimate goal actually. So that should be a culture of learning and continuous improvement. That's very, very important. This is highly noticed these days actually. So learning and being sufficiently challenging yourself. Okay, I have learned this today. I will keep on learn, invent something, and there should not be any ego. Okay, when I say ego, which means okay, I'm going to settle here. This is what all I know, and this is what like for example, I was trying to learn actually, and I don't move beyond this. This kind of thought should not be there. So learn something every day, spend some time every day and learn something. And one more thing, for example, this is what I was talking going to talk about. I used to go for campus recruit. So what I see now is like, I don't know from where this culture is coming, but what I see now is everyone talks about everything. Okay, so but the problem is they don't know much in detail. So for example, there is a say, jack of all, master of none, right? It was not promoted. We used to say this and we don't support that, jack of all, master of none. But now it looks like that culture is being supported. Try to know everything, but don't master anything. So I would strongly suggest being aware of a lot of technology, cutting edge technology, those buzzwords, good, but please master your area of interest. That is very, very important. And don't run here and there. So for example, someone says cloud today, someone says big data, and someone says this programming language and NoSQL, a lot of things you will hear for sure. But ask like what you want to be, and what your area of interest, you should master that. So when I say continuous learning, that's a very important value for engineering culture. But this is again, you should remember, like you should know your area of interest and should master it. So that's one more thing I want to say. So continuous learning is going to help you. It is like a tool. You will be, powered with that tool, empowered with that. So because there is a say, if you remember that there is a say, like the one that is most adaptable will survive actually. So the one that is most adaptable will survive. So you need to make sure that you learn something and adapt yourself. And yep, that's one important value, friends. Please make sure this. So don't think like before some years, associates in the industry, they used to think, okay, I learned this, I feel comfortable, I settle here. That's not the case now. So if you step into the industry, that's not the case now. Okay, so just this is an important value. Continuous learning. Learning is very important. And this next value, reviews. So whatever you do, this is also another important value. So whatever you do, for example, if you have a feeling like, okay, someone is there to check my work, that will add a lot of responsibility to you. That comes the reviews. So review is all about collaborative culture of learning. So this is a very important point, because you should not think like someone is monitoring you. No, the review is like not about someone is monitoring you, someone is going to punish you. No, the engineer should think like, all the engineers should think like it's a collaborative culture of learning. So whenever you go for a review, right? So like both the reviewer and the author can learn something, and there will be a knowledge sharing happens between the reviewer and author. A lot of good things, like, so good to find things worth changing actually. So he or she might be saying something, and you can share something. You come to know like, oh, okay, this is fine. And whenever the reviewer is saying some changes, think like it is good to what changing. If at all that change is going to bring some in your effectiveness in your solution, that's what changing, right? So we need to celebrate that. We should not think that, should not take, like, okay, why he is saying this, how come he can say when I have coded this tested. It's nothing like that. So things changing it's worth actually changing. We should celebrate that. This is another important value for an engineer in engineering culture actually. Because now again, the trend is like, it is not taken very easily. So it's considered like they are escalating us. No, that's not going to help. So if a team, again, another culture coming up is like, let's not do the review. So lesser the review, faster the deployment, which means let's not spend time on review, so that we can utilize that time on developing something so that we can quickly deploy. No, that's not going to actually help actually. So for example, let me yeah. So no review is going to lead, it leads to brittle code, which means um, your code will fail. So that's what the lesson learned actually. So you should know that. Moving on to the next value, blameless postmortems and team environment. Okay, if you remember in the beginning of the slide, I have mentioned blameless postmortems only, and the next is team autonomous. So I have combined both the values here. So you can see here the picture talks a lot actually. So when something is failing, the blame game starts. That's not a value of an engineer for sure. Okay. So when something is failing, yes, we gonna like correct that, resolve that. But the ultimate point is what we have learned. What is the lesson learned out of that? So what we have missed, that we should not miss the next time. That should be documented. So that kind of lesson learned is the key when any failure occurs. So whenever you do any postmortem in the sense, analyzing an issue, an application failure, a service failure, something dropped, something broken. So when you do those kind of root cause analysis, those kind of postmortem, so the lesson learned is very important. So how it failed, why it failed, like what happened actually. and what we have learned from that failure, and what kind of changes we need to apply. As simple as this. No more blame games here. And there should be a knowledge sharing and constructive discussion should happen during those kind of analysis, the postmortem timings. And set aside the criticism and negative feedback. That's what I want to mention here, because that's what I already told, right? And collectively pull together creative ideas without fear of being judged. Like, so any postmortems or any team meetings, right? So you should be able to share your ideas. Don't think like how others judge. This is another important stuff. And the attack should be towards ideas, not towards any particular person or their authority. So it should be towards ideas. The entire team should discuss in a way like they should think a lot about the lesson learned or the next ideas, next thoughts, not targeting someone and something like that. So, so you might be having a lot of strength in your team, or you being an engineer, you might be having a lot of strength. So you should not judge others also with that strength. So these kind of blameless postmortems and how a team operate, like supporting each other, sharing the ideas freely without fear, and the discussions will be all about the thoughts or ideas, not about someone or their, all those stuff. And you don't judge others with your own strength. These and all going to help a better team environment, an autonomous team actually. So these are all, I would say 7 to 8 values I talked about, and this is very, very important. So as I already told in the beginning of this session, engineering culture is very, very important, and you will be definitely might be getting to asked about that during your interviews or any other discussions. So ask about that, for example. So that's getting, as I already told, it's very important in industry now. Gone are the days where we give more, I would say like. Support to order taking kind of work, like someone tells some work and we will take the order and we will execute it and we will send it back, he will review. No, so now the weightage is giving more towards the engineering inside the engineers actually. So how you are going to re-engineering something, or how you are going to solve a problem through your engineering. So that's it. So for example, last but not least, so an engineering culture builds better software than expert developers. This is how the industry is thinking now. So you should understand. Than the expert developers, the culture is very important. Better to have inexperienced developers work together in an amazing engineering culture to deliver. Okay, compared to a team of expert programmers, they deliver something in a harsh environment. No one is going to like that harsh environment. Something with an amazing engineering culture will be liked by everyone. And that's what the industry is expecting actually from each and every engineers. So don't need to be experts in everything. Yes, when you just join in after completing your engineering education, you trained your mind to think. When you join the industry, you won't be an expert. You are going to learn something, but we do need to set ourselves up with an engineering culture. So this you should be needed. So this is how the industry is thinking now. So you don't need to be an expert, but when you come with a better, good culture, okay, that's going to breed success for sure. So that's what engineering culture is all about. So the last slide, the 3 points I showed, this is how the industry is thinking now. That shows the importance of engineering actually, engineering culture actually. So that's what I also thought of telling this, because I see through a lot of campus recruits or the interviews I do, I see like the importance towards engineering culture is missing. That's what I thought. Okay, instead of touching the technology part, this is very important now. That's what I was talking about this. So this is the session is all about that. Thanks a lot, friends. Thanks for your time. Thanks again, everyone. Thanks for the management. Thank you all. I hope you had a good time listening to this. Thank you all. Bye-bye.
Thank you, sir, for such a wonderful and informative talk. Concluding the session with vote of thanks, I request Mr. P. Kannan sir, Assistant Professor, ECE Department, to deliver vote of thanks.
Good morning, all of you. It's a great honor to propose a vote of thanks on this special occasion. First of all, I thank Lord Almighty for giving this opportunity to conduct this webinar. At the outset, I thank the resource person, Mr. Abdul Riyaz, for having presented the webinar on engineering culture and technology evaluation. Sir, on behalf of ECE department, I thank you for your wonderful webinar, sir. Next, I thank the management for their guidance and motivations to organize webinars during this lockdown to make our students and other participants enrich their knowledge in relevant fields. Next, my sincere thanks to Dr. K. Jayakumar, General Manager Development, and Dr. B. Velmurugan, Principal, for their endless support. Thank you, sir. Further, I take this opportunity to thank Professor J. Friska, Head of the Department, for her valuable advice and direction towards making this webinar in a grand success. Thank you, ma'am. I thank the coordinator of this event and all the faculty members of ECE department. Finally, my sincere gratitude to all the participants for your active participation. Thank you, one and all. Thank you.
The feedback link will be provided in the comment section. Participants kindly fill the feedback link. Thank you.